All right, welcome guys. Today we're doing lesson 7.3 on solving linear systems by elimination, or sometimes it's called adding and subtracting. So we've already learned a couple ways to solve linear systems. That first way was by graphing and the second way was by substitution. And so now we're going to learn a third way to solve a linear system. So remember that a linear system is a system of two or more equations that have two variables. So as you look down below here, you see an example of a linear system. And when we solve the linear system, we are looking for an ordered pair, a point, that is a solution to both equations. And so no matter what method we use, when we have a linear system, whether we graph it, use substitution, or this new method we're learning today, you're going to get the same answer. But depending on the form that the linear systems are given to you in, one method might be easier to use than another. So if you would, please pause this video right now and write down steps 1, 2, and 3. All right, so in these steps, what we're going to do is we're going to be adding or subtracting the equations together to eliminate one of the variables. We're either going to try to eliminate x or eliminate y, because if we can eliminate one of them, then we can solve the resulting equation for the other variable. In other words, if we can eliminate x, then we can solve to figure out what y is, and if we can eliminate y, then we can solve to figure out what x is. And then once we figure out x or y, step 3 is actually the same step that we did when we used the substitution method, where we will substitute it into one of the original equations to find the value of the eliminated variable. In other words, if we eliminate x, we'll solve for y, then we'll plug y in to figure out x. And similarly, if we eliminate y, we'll solve for x, we'll plug x in to figure out y. Again, once we start working through this, I think it'll make even more sense to you. All right, so let's start with this first example. You'll see we have two equations, and I'm going to write those down here so we can start working with them. So we have 2x plus 3y equals 11, and then negative 2x plus 5y equals 13. Now, what I want you to notice, first of all, is that we have in this equation the x's lined up, the y's lined up, the equal signs lined up, and the constants lined up. And that's important. Before you can start eliminating, everything has to be lined up. So in the initial examples that we do, everything will be lined up nicely for you. And then in the part 2 video, we'll start exploring what happens if they aren't lined up. But for right now, they are. And so we don't need to worry about doing anything to get them organized because they're already how we want. Okay, now, what we're looking is there some way that we could eliminate the x's or eliminate the y's? Well, what I hope you notice is because we have a positive 2 and a negative 2, those are going to be pretty easy for us to eliminate. So if I add these two equations together, 2x plus negative 2x is 0x. In other words, those eliminate. Now, if I'm going to add, I have to add all of the different pieces. So I also have to do 3y plus 5y, that's 8y. Bring down the equal sign. 11 plus 13 is 24. But what we have now is an equation that only has a y because we have eliminated the x, and therefore we can solve for what y is by just dividing by 8 and getting that y equals 3. And so now we're already halfway there. We now know what one of the coordinates is. And so step 3 is just like what we did before. We can take that y equals 3 and plug it into either equation. And so I'm going to go ahead and start by plugging it into the first one. So instead of y, I'm going to plug in 3. And then I'm going to solve for x. So I'm going to multiply and then subtract 9, which gives me 2x equals 2. And when I have that 2x equals 2, I can divide each side by 2 to get that x equals 1. And then let me show you that it doesn't matter what equation you plug it into, just like before. Again, you don't need to plug it into both equations. I'm just trying to prove to you that it's going to work either way. So here I would multiply and then subtract 15, and I get negative 2x equals negative 2. And so when I divide by -2, I again get x equals 1, okay? Again, you don't need to plug it into both equations. I'm just showing you that no matter which equation you plug it into, x comes out the same. And so now I have my solution is 1, 3. Again, make sure you put it in the correct order. X comes first and then y. All right, now, just like with the substitution, I'm not going to require that you do check steps, but it is a good idea to just quickly plug it back in to make sure it works. And on these first couple of examples, we are going to do check steps just to confirm that we have gotten the right answer. So we're hoping that we got an ordered pair that produces a true statement when plugged into both equations. So we think x is 1 and y is 3. So we're going to plug this in. In the first equation, we have 2 times 1 plus 3 times 3, and that should equal 11. So that's 2 plus 9, which is 11. So we're good on the first equation. Then we'll take the second equation, and so we have -2 times 1 plus 5 times 3 equals 13. So that's -2 plus 15, which is in fact 13. So since it worked for both equations, we know we have the correct solution. Now, just a quick note here, if we had taken these two equations and graphed them both, they would intersect at the point 1, 3. And we could have also done substitution. We could have isolated the x or the y and substituted it into the other, and we would have gotten the solution 1, 3. No matter what method you use, the solution to this system is 1, 3. We're learning 3 different ways that we could get that answer, because again, depending on the format that they give you these problems in, one method might be easier to use than another. All right, let's go ahead and take a look at the second example. So again here, you'll notice that we have 2 equations, and these as well are already lined up for us, so we can just copy them down below. We have the x's lined up, the y's lined up, the equal signs lined up, and the constants lined up, so that's great. But what you'll notice is if we do exactly what we did on the last one, if we add these two together, we get 9x plus 6y equals 0. Now, what we've done is mathematically correct, but this is not helpful to us because we haven't eliminated either of the variables. We still have an x and we still have a y, so we're no better off than when we started. So that's not going to work to add them just like we did before. So I'm going to undo all of that. And we've got to figure out another way to eliminate. Okay, well, hopefully what you notice here is we have this 3y and 3y. So if we try to think of a way that we could eliminate the y's, hopefully what you notice is that we could subtract the equations. And if we do 3y minus 3y, that's 0y, so that eliminates. Okay, so if we're going to subtract those, we need to subtract all of the pieces. And so you've got to be a little more careful with this because there's going to be more negative signs here. So for example, 4x minus 5x is negative 1x. And if you need to keep change in that little part there, you can. But 4x minus 5x is negative 1x. Then 3y minus 3y, that's what eliminates, which is good. That's what we're trying to do, is get something to eliminate. Now here, be careful. We have 2 minus negative 2. If it helps you, write it over to the side horizontally to make sure you don't mess up those negative signs, because that's positive 4 there. All right, so then I'm going to divide by -1, and I get that x equals -4, which is great because, again, I'm halfway there. I now know what one of my coordinates is. As soon as I know that, then I can plug -4 into either equation. So I'll go ahead and just plug it into the first one. I have 4 times -4 plus 3y equals 2. So that's -16 plus 3y equals 2. I'm going to add 16 to both sides, again, because I'm trying to get the y by itself. So I have 3y equals 18. Divide by 3, and I get that y equals 6. And again, I could have plugged that -4 into the second equation, and I still would have gotten that y equals positive 6. So now I have my solution. It's -4, 6. And again, I'm going to do a quick little check step here to make sure that I got the right thing. You are not required to do a check step, but it's a good way to just really quickly know that you got the right answer. All right, so I think x is -4, and I think y is 6. So here I'd have -16 plus 18, which is positive 2, so that one worked. Then I need to take my second equation, which is 5x, so 5 times negative 4, plus 3y, so 3 times 6, and that needs to equal negative 2. So this would be negative 20 plus 18, and yep, that's negative 2. So again, I know I found the right answer because when I plug it into each equation, I get a true statement. So what you'll notice is when you're doing this, sometimes you have to add the equations and sometimes you have to subtract the equations. You need to do whatever it takes to eliminate one of the variables. So now let's practice, and we'll first have to determine if we add or subtract and then work it from there. All right, so let's take a look at example 1. My goal is to either eliminate x or eliminate y. So I need to look and see what I can do to get rid of something. So again, whenever they have the same coefficient, that's the clear sign that that can be eliminated. So I see this negative 3y and positive 3y, and so I know I can add those to eliminate that. So 4x plus negative 2x is positive 2x, and then negative 3y plus 3y eliminates, which again, that was my goal. And then 5 plus negative 7 is negative 2. And so I've eliminated the y, so I can quickly figure out what x is, and x is negative 1. Then I'm going to plug that into either equation. So I'll plug it into the first one. 4 times negative 1 minus 3y equals 5. So this is negative 4 minus 3y equals 5. Add 4 to each side. Negative 3y equals 9. Divide by negative 3. And you get y is negative 3. Okay, again, then don't forget the final step, which is you need to write your answer as an ordered pair. So x is negative 1, y is negative 3, so that's the ordered pair, negative 1 comma negative 3. And again, you can do a quick check. You don't even need to like write it out carefully. But if I plug in here, I'm trying to get this, here we go. I'm trying to erase my marks here so you can see it more clearly. Okay, so here I would have 4 times negative 1, that's negative 4, and then negative 3 times negative 3 would be plus 9, and yep, that's 5. So see how quickly you can just kind of do it there. Negative 2 times negative 1 is positive 2. 3 times negative 3 is negative 9, and yep, we see that that gets us negative 7. So you don't need to write out like a whole check step, but you can still do it very quickly to make sure that it works. All right, let's try number 2 now. So again, I'm looking and I see that here everything's lined up, which is good. And I've got this negative 5x and 5x, so I can see right away that that's what's going to eliminate. I need to think if I need to add or subtract, and on this one again, I need to add because negative 5x plus 5x eliminates, and again, that's my goal. Then I'm adding all the other pieces. Negative 6y plus 2y is negative 4y. 8 plus 4 is 12. I divide each side by negative 4, and I get y is negative 3. Again, I'm halfway there. So now I'm going to plug that negative 3 into either equation. I'm going to go ahead and take the second equation just because that one has more positives. And again, I like to make it as easy as I can. So this would be 2 times negative 3 equals 4. So I get 5x plus negative 6 equals 4. Add 6 to each side. You get 5x equals 10. Divide by 5, and x equals 2. So my ordered pair is 2 comma negative 3. Again, I always encourage you to go back really quick. So I'm going to erase my marks there to do my check step. So here I'd have 2 times negative 5, that's negative 10, plus this would be positive 18 when I have that negative 3 times negative 6. And yep, that does equal positive 8. So the first equation works. And then the second equation, I have 2 plus negative 6, and yep, I see that that's 4. So again, a real quick check there to make sure it makes a true statement for both is a good idea. All right, so why don't you pause the video right now and try number 3 and 4, and then press play when you're ready to check your answers. All right, go ahead and check your answers with mine. So you'll notice in number 3 that because I had a positive 7x and a positive 7x, to get those to eliminate, I needed to subtract. And so 7x minus 7x eliminated, which was my goal. Then you've got to be careful, and I wrote it over here to the side because it can get tricky for people, but we have negative 2y minus negative 3y. So that's really negative 2y plus 3y, which is where I got that positive 1y. And then 5 minus 4 is 1. Again, whatever you have to do to eliminate, you've got to, if you add to eliminate, you have to add all the way across. If you subtract to eliminate, you have to subtract all of the pieces. So I got y was 1. When I plugged that in, I ended up getting the x was 1, so the ordered pair is 1, 1. And again, you can do a quick little check step here. This would be 7 times 1 is 7. Negative 2 times 1 is negative 2, and 7 minus 2 is 5, so the first equation works. The second one, again, 7 times 1 is 7, and then this would be minus 3, and yep, that's 4, so we see that it works in both equations. On number 4, because I had a negative 4y and a positive 4y, to get that to eliminate, I needed to add. So then I ended up with 3x equals 15, so x was 5, and when you plugged that in, I got that y was 4. So now let's double check that really quick. So 6 times 5 is 30, 4 times 4 is 16, so 30 minus 16 is 14, so the first equation works, great. And then in my second equation, I get negative 15, and then plus 4 times 4 is 16, and negative 15 plus 16 is 1. So that one works as well. All right, so this is where we're going to stop in the part 1 video. The part 2 video of this same lesson is going to show you what to do if the equations don't match up perfectly, because you can still use elimination, but you're just going to have to do an extra step to get them to line up. But this is the end of part 1. Have a great day.